AI broke the internet again. And this week has been absolutely insane. We've got Microsoft going completely full send on their own AI model family. We're talking a thinking model, a transcription model, a voice model, a coding model, a new image model, and Flash variants on top of all of that. We've also got a new research model that lets AI characters stream live audio and video simultaneously. We have a new AI system that can reconstruct full 3D geometry from a single panoramic image. And JetBrains just dropped Mellum 2, a fully open source coding-focused model with a built-in thinking mode, and a lot more. So let's jump right in. First up, Microsoft just had their Build 2026 conference. And honestly, this is a pretty huge deal for anyone watching the AI model race. So Microsoft has their own internal AI research division, the MAI Superintelligence team. And this week, they basically unveiled an entire model family. Not one model, not two. We're talking about 7 distinct models spanning reasoning, image generation, transcription, voice, and code. Let's go through them. MAI Thinking 1 is their new reasoning model, announced at Build 2026. This is Microsoft's direct entry into the thinking model space, competing with the likes of O3 and DeepSeek R1. Not a ton of public benchmarks out yet, but this is clearly them saying they want their own frontier reasoning model, not just reselling OpenAI. MAI Image 2.5 is the one with the concrete benchmark number you can point to. It launched at number 3 on the Arena text-to-image leaderboard, and number 3 globally is not a joke. According to Microsoft's announcement, it delivers a step change improvement over MAI Image 2, specifically in text rendering, stylized illustration, and commercial and brand imagery. So I want to show you some of the actual examples from their page, because this is where it gets interesting. On screen, you'll see a few of the official samples. A green ice cream tub labeled Darcy's with clean, sharp product typography. A bag of chips labeled Chip Chips with spot-on packaging design. A group of people next to a red car in a cinematic lifestyle shot, and what looks like a floral garden scene. These are all outputs from MAI Image 2.5 itself. If you're interested in trying it out, I'll link to the Arena page in the description below. MAI Transcribe 1.5 is their speech-to-text model, and this one has a really interesting benchmark story. On the FLIRS benchmark, which tests transcription accuracy across 25 languages, MAI Transcribe 1 achieves the lowest word error rate against every major competitor. According to Microsoft's official page, it beats Scribe v2, Whisper Large v3, GPT Transcribe, and Gemini 3.1 Flashlight. It's also 2.5 times faster than Microsoft's own existing Azure Fast offering, and the pricing they've set is 36 cents per audio, which they're positioning as the best price to performance of any large cloud provider. But the part I actually found most interesting on their page was the real-world noise demos. They have 3 actual audio clips showing what the model does in messy, real-world environments, not clean studio recordings. The first one is a cafe scenario. Background noise, ambient chatter, and the model transcribes.
Hey, so I was hoping to change my flight, if that's at all possible. It's currently set for 10 p.m. tonight, but I'm going to try to switch to something earlier. Ideally, sometime before 6 p.m. Is that something we could maybe look into?
Completely clean. Or here's an even trickier one, an office scenario in Spanish with code switching mid-sentence. The transcription comes out as,
Oh, someone else is joining us. Oh, hello. Please come in, join us. We'll switch to English, no problem. Sí, bienvenido.
That's genuinely hard. MAI Transcribe is live on Azure Foundry now, with the 1.5 version also announced. If you're interested in reading further, I'll link to the full announcement page in the description below. MAI Voice 2, the voice generation model. MAI Voice 1 could already generate 60 seconds of audio in just 1 second, and had custom voice cloning built in with just a few seconds of audio. MAI Voice 2 was announced at Build 2026 as the next step. The catalog page isn't public yet, but if you want to hear Voice 1 in action, it's already powering Copilot audio expressions and Copilot podcasts. I'll link both below. MAI Code 1 Flash is integrated directly into GitHub Copilot and VS Code, already live for Copilot subscribers. Flash variants are also coming for MAI Image 2.5 and MAI Voice 2, lighter, faster, cheaper versions of the flagships. The big picture. Microsoft is no longer just an OpenAI reseller. They are building their own full model stack. Thinking, image, voice, transcription, code, every major modality. If you're interested in reading further, I'll link to the Microsoft AI news page in the description below. Also this week, we have a really interesting new research model called StreamChar, and this one is genuinely fascinating. So the problem with current AI avatar and character systems is that audio and video get generated separately. You synthesize the speech first, then animate a face to match. That works for pre-recorded content, but it completely breaks down for live, real-time interactions. StreamChar fixes this with a streaming DIT backbone. DIT stands for Diffusion Transformer. The key innovation is what they call decoupled LLM orchestration with joint audio-video DIT denoising. In other words, the language model handles the what to say part, and the DIT handles the how it looks and sounds part simultaneously in a single streaming pipeline. The result is a system that can generate synchronized character audio and video continuously. Long horizon streaming, meaning it doesn't have a hard time cap the way most video generation models do. They also use something called sync chunk memory and online rollout distillation. These are the architectural tricks that keep character identity consistent across long sessions without the model drifting. Now let me show you what this actually looks like in practice, because the demos on their project page are pretty wild. The first example is a product pitch scenario. The prompt given to the model is a creator holding a pen in one hand, slowly demonstrating it while gesturing with the other. And the character streams out a full sales pitch in real time, something like,
Guys, you literally have to try this makeup pen that feels like it was designed by angels for anyone who's ever struggled with shaky hands, because the moment you glide this micro precision tip across your skin, you realize it's not just an eyeliner or brow pencil, but a total game changer that instantly upgrades your look from just woke up to red carpet ready with its buttery smooth, smudge-proof formula that stays put through coffee runs and late night parties, proving that you don't need hours of practice to achieve professional grade wings or perfectly arching brows.
Or here's an even trickier example. A motion control demo. They give the model a scheduled sequence of physical actions, and the character executes all of those motions across streaming chunks in order while continuing to speak naturally. The transcript running underneath is completely unscripted sounding. Body control and speech generation happening live, in sync with motion sequencing on top. There are general usage demos go even further, but the most impressive demo is the long horizon generation test. They feed both characters the same long transcript, a continuous monologue that runs for several minutes, and both characters stream through the entire thing independently, maintaining appearance consistency, natural movement, and correct lip sync throughout. That's the part that's genuinely hard. Most video generation models drift after a few seconds. StreamChar holds character identity across what looks like several minutes of continuous output. This is a research release from Human AIGC, the same lab behind Animate Anyone, under Alibaba's Tongyi team. The project page has all the demo videos at native resolution. If you're interested in reading further, I'll link to the project page in the description below. Also this week, this project is a really interesting shift in how 3D geometry reconstruction from panoramic images actually works. And the benchmark numbers here are legitimately impressive. It's called Page Panoramic Geometry Reconstruction out of ETH Zurich, with researchers from Google and Meta. Here's the core problem. We've got solid AI models for estimating 3D depth from regular flat photos, but 360-degree panoramic images, kind you get from an Insta360 or a LiDAR scanner, break those models badly. The polar distortion is too different from what they were trained on. Pager's solution is clever. Instead of feeding the panorama directly to the model, it first projects it into 6 cube faces. You unfold the 360-degree sphere into a cube. Then you feed those 6 faces to the model as if they're 6 regular photos taken from a single point. The model already knows how to handle regular photos, and since the cube faces share edges, the geometry stays coherent. One forward pass produces 4 outputs simultaneously: scale invariant depth, metric depth in actual meters, surface normals, and a sky mask. Now let's look at what the actual benchmarks show, because this is where it gets wild. On scale invariant depth, across 3 benchmarks, the results are on screen. On Matterport 3D 360, Pager hits an ABS-REL error of 9.67% compared to DA squared at 11.06%, Unikay 3D at 14.82%, and Moji at 18.12%. On Zurapano, the real-world outdoor benchmark with actual LiDAR captured Zurich street scans, DA squared, which is one of the strongest perspective models, completely falls apart with an ABS-REL of 61.22%. Pager, 9.36%. That's not a small gap. That's a 6 times improvement on outdoor scenes. On surface normals, Pager beats every specialist model, including Panonormal, Hypersphere, and Monoveet, even though those were trained specifically on this task in domain. Pager is a unified model that handles all 4 geometry tasks at once, and it still wins on normals. The project page has interactive comparisons. Drag sliders to compare Pager against DA squared on depth, against MTL on surface normals, and rotating 3D point cloud visualizations side by side. The difference in coherence on the point clouds is pretty obvious. The awesome thing is, they've already released the code, the weights, and both datasets, Pano Infinigen and Zuri Pano, all on Hugging Face and GitHub. With a live demo you can try. If you're interested in reading further, I'll link to the project page and the paper in the description below. Also, this week, JetBrains just released Mellum 2, and for anyone who does a lot of coding work, this one is worth your attention. So Mellum is JetBrains' open source coding model. Same company behind IntelliJ, PyCharm, WebStorm. They built this specifically for coding and agentic development workflows. Mellum 2 is a 12 billion parameter model, but uses a mixture of experts architecture with 64 experts, and it only activates 2.5 billion parameters per token. Think of it like a room of 64 specialists, where only 8 step in to handle any given task. Specialist level quality without paying for all 64 at once. Context is 131,072 tokens. License is Apache 2, fully commercial. Now let's go through the benchmarks from their official page, because this is where the thinking variant specifically stands out. On Live Code Bench v6, which tests real coding ability on recent problems, Mellum 2 Thinking scores 69.9%. For comparison, Qwen 3.54b hits 59.4%. Qwen 3.59b hits 68.3%, and Ministral 3 at 14b, a much larger model, only hits 42.7%. Mellum 2 Thinking is beating a 14b model on code with just 2.5b active parameters. That is cracked. Or here's an even more interesting number on JetBrains' own internal pairwise eval, which tests specifically for IDE-relevant coding quality. Mellum 2 Thinking scores 69.5%. Qwen 3.54b scores 40.5%. Qwen 3.59b scores 56.7%. This is the benchmark built by the people who make the IDE, testing for exactly what matters in a dev environment. On math, AIME 2025 plus 2026, average, it scores 58.4%. Not the top of the table. Qwen 3.59b beats it there at 73.4%, but pretty strong for a 2.5 billion active model. One benchmark where I'll flag the number honestly, GPQ a Diamond, which tests graduate-level scientific knowledge. Mellum 2 Thinking scores 57.6%, while Qwen 3.59b scores 81.3%. So if your use case involves heavy scientific reasoning outside of code, Qwen might be the better call. But for pure coding and IDE-integrated agentic workflows, Mellum 2 makes a strong case. The model emits reasoning inside think tags before giving the final answer. Same pattern as DeepSeek R1. It's trained with RL using verifiable rewards on top of the SFT checkpoint. The awesome thing is they've released everything. Base, Instruct, and Thinking variants all on Hugging Face under Apache 2. If you're interested in reading further, I'll link to the model page in the description below. And that sums up the key AI news for this week. As always, I will be on the lookout for the top AI news and tools to share with you. Remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. Thanks for watching, and I'll see you in the next one.